is back to its what? Original shape, right? So can you all guess what will happen after you carry out process annealing? Stage 2, after what? You remove the what? Plastic what? Strain. Are we clear? Then you do it again. What do? You stretch it again. Then you carry out process annealing. Then after that, stretch it again. Why is it called process annealing? Because it's done in between the process. Okay. Now, when do we actually like have to do this? Okay. Remember about our story about case study on oozeball, yes or no? Right. How do we deform oozeball? Heat it up. You heat it up at what? At about 900, 950 degrees C. We bend, and then what? We stretch. For this case, okay, when you do process annealing, right? Where did I? For this case, when we do process annealing, we have to carry out process annealing when we do what? I.e., the company don't have the infrastructure to spend to heat up the material, and immediately after heat it up, you what? Bend it. It's not easy to do set up like this, by the way. It's not easy. It's not like, you know, if this is in a third world country where it's cheap like Indonesia or Vietnam, they could get a guy using an acetylene torch. And then okay, torch down. Acetylene torch down here, light up his cigarette. Yeah, we bend. Have you all worked in any workplace like that in Canada? In other countries, yeah. Not here. Health and safety is really what? Too important in this country. Yes or no? Right? So we can't do that. Okay. So how do people do co-working? Like if they have a lot of parts to make, first of all, they will bend the part like 1,000 pieces. After they bend it for 1,000 pieces, they send it to the what? The furnace to do what? Filling, and they bring it back. So this is where we carry out what? Process annealing. Okay. Right. So you can see how the stress state changes. Okay. After process annealing, right? You more or less like remove what? Okay. So after process annealing, okay, the plastic strain is set back to what? To 0 what? Again. Okay. So when go back to 0 means you can deform by what? The next time you deform, okay, I use a different color, it will go up. Yes. It will do this. Yes. And then it will come back down again. And then it goes through a what? Through a cycle. So if you're going to buy a car that it has gone through accident, you will tell them is after accident, did the structure go through process annealing? You know what I'm going to tell you? We don't know. Right? It's too costly to do what? Process annealing. So if we go back to the graph, Okay. This is only carry out, okay, if your carbon is less than what? 0.3. More than that, okay, it will not be as effective. Okay. I need to apologize. I did not find out why. Okay, I only read the textbook. It said only do up to 0.3% carbon. Okay, I will do some research to tell you all why later on. Okay, one thing I want you to observe, at 0.3, the upper limit is less than what? Less than the 723 what? Degree C, yes or no? Why? Because you don't, if you go more than that, you will change the percentage of ferrite and what? Pearlite. You don't want recrystallization to occur, but you want the microstructure to change its what? Shape. Are we clear? Okay. So you can see from here in process annealing, okay, no recrystallization occurs. So, i.e., the percentage of ferrite and pearlite will not change after what? Process annealing. When I was an undergrad, I really hate this topic of heat treatment. Make no sense. But when I put into an application, you can see the value, yes or no? If I just say, okay, process annealing, you just heat the thing up 0.3%, you know, take it out, you know, change its shape. What's the point? Are we clear? Okay, so example does help. Okay. And then the next one that we are going to do, okay, is what we call stress relief annealing. Okay, it's what we call stress relief annealing. So the stress relief annealing, okay, if we go back to our big graph, okay, and I'm going to use a green line. And this is just a line. Okay. So you can do stress relief anneal regardless of percentage of carbon. Okay. So you can move the temperature higher, temperature lower. So this is temperature for stress relief anneal. Okay. Now, can you all write down here? I forgot over here. This is our process annealing. Okay. So that is our temperature for our stress relief anneal. Okay. So I'm going to write so in stress relief anneal, oh, different color. Okay, stress relief anneal is used, okay, to remove geometric distortion induced by manufacturing process. Okay. So it's usually reduced or remove, okay, the unwanted tensile residual stresses induced or generated by casting or welding. Okay. So in stress relief anneal, the material is heated up and followed by controlled cooling. Okay. So there are differences. Okay, so I'm going to write this. So what are the difference between process annealing and stress relief anneal? So one of the difference is the stress relief anneal is usually carried out as the final heat treatment stage. Okay. And the second thing that's different can be carried out at any percentage of carbon. Okay. And the third thing, you have no recrystallization. So i.e., the microstructure shape will not change its shape. Not like the one I drew before is oval in shape, right? In stress relief anneal, after stress, it will still be oval. It will not be round. Okay. So this is more for correcting what? Geometry. Okay. If you were to manufacture a part, then it is like bend. Okay. Then you do stress relief anneal. Now, if we go back to our diagram over here, okay, we go back to a diagram. What temperature to do it? It's trial and error. Okay, so what do I mean? Okay, so when, okay, so the temperature Okay, let me give me like, you know what? No, give me like 1 more minute, okay? So the higher the higher the temperature used in during stress relief anneal, okay, the less time is required to remove the unwanted stresses or distortion or geometric distortion. However, more time will be what? Spent during what? Controlled cooling. Okay, you need more time. So what do I mean? Okay, so let's this is just an example. Okay, go for a break. Okay, you listen 1.5 hours of my voice. I don't know how you guys could stand it. Go for a break. Okay, and then we come back again.